Okay. Good morning, children. Here we have another numerical from NCERT, that is question number 6.12. In this question, enthalpy of formation of carbon monoxide, carbon dioxide, nitrous oxide, nitrogen tetroxide, these are given, and we have to find out enthalpy of this reaction. We are asked to find out uh, enthalpy of reaction. We have to find out for this reaction. As I said, the relation is summation of enthalpy of formation of products minus summation of enthalpy of formation of reactants. As I was telling in the previous video, application of enthalpy of formations data. Using enthalpy of formation data, we can find out enthalpy of reaction. So this numerical is to that effect. So putting these values, we can write this one as product. So enthalpy of formation of N2O plus 3 into enthalpy of formation of CO2 minus enthalpy of formation of N2O4 minus 3 into enthalpy of formation of carbon monoxide. So now just you have to put the values that are given. N2O2 is 81 plus 3 into carbon dioxide is minus 3 into 3. We have 3 into minus 393 minus N2O2, it is 9.7 minus 3 into enthalpy of formation of carbon monoxide is minus 110. So if you simplify this, you get the answer in kilojoules per mole. So this is how you get the answer. Now I can tell you one thing here. You see, enthalpy of formation of carbon monoxide and carbon dioxide both are minus, and the enthalpy of formation of these two compounds, it's plus. This enthalpy of formation value, can tell us about stability of the compound. More negative the value of enthalpy of formation, you should know more stable the compound is. So you see, out of all these compounds, most stable compound here is carbon dioxide. It's because it's highly negative, and least stable will be our N2O, because it has highest positive value of enthalpy of formation. Okay, now when you do numericals, you will come across different types of enthalpy. Different types of enthalpy you will come across. Say number one, enthalpy of combustion. Enthalpy of combustion. What is enthalpy of combustion? Combustion means burning. So if or rather when 1 mole of a compound is burned in excess of oxygen, the heat change that takes place is called enthalpy of combustion. Okay, I am writing here some process. Say carbon solid plus O2 gas, arrow CO2 gas. So here you see it is 1 mole of carbon. It is being burnt, and we get this is a product. So the corresponding enthalpy of reaction here, it is called the enthalpy of combustion. Okay, let me take a hydrocarbon. You know, hydrocarbons are good fuel. They, CH4, gaseous. Methane is a gaseous. So, if methane is burnt, so product will be CO2 gaseous plus H2O liquid. H2 liquid. Now here also we need to burn 1 mole always in case of enthalpy of combustion. Keeping this 1 mole, we have to balance this equation. Keeping this 1 mole, so now hydrogen is 4 here, so 2 times here, and you can see in the right side we have oxygen 2 and 2, 4 oxygen. To keep it 4 oxygen, we have to put here 2. So this is a balanced chemical equation for combustion of methane, and the enthalpy change that happens here will be called as enthalpy of combustion. Enthalpy of combustion. Okay, now children, we have written so many equations of this type, where in the equation the physical state of the substances are mentioned. Say it's gaseous here, it's gaseous here, water is liquid here. If physical states are mentioned, and enthalpy value is also mentioned after the reaction, then these are called, this equation of this type are called thermochemical equation. These are called thermochemical equation. So this is about enthalpy of combustion. So remember, 1 mole of fuel, 1 mole of substance has to be burned. Then you have enthalpy of atomization. There is a term called enthalpy of atomization. What is that? Suppose this change, you see carbon solid to carbon gas. Carbon solid to carbon gas. Here carbon is changing into atom form. Carbon gaseous means atom form, and here also we have to take 1 mole of this substance. 1 mole, then the corresponding enthalpy change will be called as enthalpy of atomization. Let me give one more example of enthalpy of atomization. Suppose H2 gas, arrow 2H gas. So here you see we have 1 mole of hydrogen here, 1 mole, and that is changing into atom, and the enthalpy change here is called the enthalpy of atomization. Now, as already has been said, these are thermochemical equation, and when thermochemical equation, we can use thermochemical equation just like mathematical equation in mathematics. I mean, if we multiply, suppose we multiply this equation by 2, here 2, here 2, here 2, if I multiply, then the enthalpy change value also gets multiplied by the same number. Suppose if I divide both sides of the equation by say 3, the enthalpy value also will get divided by 3. So this is the property of thermochemical equation. This we have to remember. We are going to use this. Suppose we are adding this to equation, then the enthalpy value also will get added. Okay, so now let us do another numerical of NCERT book. okay, which is very important. So children, see question number 14. In the 14, these three equations are given, and there, say enthalpy of reaction, standard enthalpy of reaction is given. This is standard enthalpy of combustion is given. Here, standard enthalpy of formation is given. Now, using this value, we have to find standard enthalpy of formation of methyl alcohol. Okay, you may not be seeing, but it is standard enthalpy of formation of methyl alcohol we are asked to find out. So, you see, this can be done in this way. Let us choose this equation. Let us choose this equation, and we can write this thing, delta H naught R is equal to this enthalpy of reaction. It is a summation of enthalpy of formation of products minus summation of enthalpy of formation of reactants. This we know, and if we choose this equation, then you see we have product carbon dioxide, so we can write that enthalpy of formation of CO2 standard plus 2 into enthalpy of formation standard of water. So this shows the products, and the reactants minus standard enthalpy of formation of methyl alcohol. This quantity only we are asked to find out, and you see here this is free element. This is free element. Standard enthalpy of formation of free element are 0. So its value will be 0. So that's why I'm not writing this value. Okay. After that, this reaction value is minus 726. Let me write minus 726. Okay. Now enthalpy of formation of carbon dioxide. We need enthalpy of formation of carbon dioxide. Now you see here, this is 1 mole of carbon dioxide formed here from the constant element. So this value, which is given as enthalpy of combustion, we can take it as enthalpy of formation of carbon dioxide. This you have to understand. This standard enthalpy of combustion of graphite will be same as standard enthalpy of formation of carbon dioxide. So using this value, minus 393 plus, now enthalpy of formation of water is given. So here 2 moles, so 2 minus 286 minus this value. Suppose we need to find out this value, let it be x. So children, you see, on simplifying this, we can calculate x, then we will get the enthalpy of formation of methyl alcohol. So like this, questions will be there in your exam. Okay, you have to do like this. Okay, now next topic I am doing is bond enthalpy. Another type of enthalpy, bond enthalpy. Now suppose we consider this bond, to break this bond, energy will be required, and energy required to break 1 mole of bond. Energy required to break 1 mole of bond is called bond enthalpy, or it's also called bond energy. 1 mole of bond. So for the process that we can write is H physical state. Suppose if I give it is gaseous, it is also gaseous. This process we can write also like H2 gaseous, arrow 2H gaseous. So you see 1 mole of bond, 1 mole of bond is being broken, and the corresponding enthalpy change will be called as bond enthalpy. I am giving the value of hydrogen. It is 435.8. It is 435.8 kilojoules per mole. So this is called bond enthalpy. Now suppose one thing here, if I reverse this equation, that means if I write this way, 2H gaseous, arrow H2 gaseous. So I have reversed the equation. Now this is a property of thermochemical equation. If I reverse the equation, this enthalpy value will remain the same, but sign will change. So for this process, delta H value will be, here it was 435.8, so it will be minus 435.8 kilojoules per mole. Minus 435.8 kilojoules per mole. Here you should understand this thing, here you see this process, here bond is being formed. 1 mole of bond is being formed, and the meaning of this equation is that when 1 mole of this bond is formed, this much energy is released. Remember always, when bond is broken, energy is required, and when bond is formed, energy is released. So now you see in your book, you see in your book there is a table. Here, okay, and bond enthalpy of various bonds are given. Suppose you should know how to read this value. Suppose we want to find bond enthalpy of HBr bond. Now you see here it is Br, and here you have to have H. So H and Br, where it is meeting, here it is 368. So 368 kilojoules per mole is the bond enthalpy of HBr. Suppose I need the bond enthalpy of S chlorine bond, sulfur chlorine bond. So here you see sulfur, and here is chlorine. So sulfur and chlorine, suppose the sulfur is here and chlorine is here. So where they are meeting, it will give us the sulfur chlorine bond enthalpy. So now this bond enthalpy also has got importance. From bond enthalpy values also we can calculate enthalpy of reaction. Okay, from bond enthalpy values also we can calculate enthalpy of reaction. That relation I am giving. How to calculate enthalpy of reaction from bond enthalpy data. So the relation will be this one will be the relation. standard enthalpy of reaction, will be summation of bond enthalpy of reactants. Here we have to write of reactant first, then minus bond enthalpy of products. So using this relation, using this bond enthalpy data, we can find out standard enthalpy of reaction. In the next video, okay, we will start with the numerical, and we will be seeing how using bond enthalpy value we can find out, we can calculate standard enthalpy of reaction. So till then, bye bye and have a good day.